Yeah.
Okay, this is a confidence interval. Find the 95% confidence interval for the difference of the means. You're going to assume the variances are equal here. This is still number 11 on section 9.4. We're going to go back over here and we're going to find the difference between our means, between our sample means, which if we look over here, we just did this up here. 17 minus 16.667 was 0.333. So notice it's the same thing we did with this formula. So the difference between these two means, when we subtract them, is 0.333. We figured that out earlier. Our t-score. We haven't figured out our t-score yet. You need to go into your t-chart, go to degrees of freedom of what again? 10, right? 6 plus 6 minus 2 is 10. And it's two-tailed. And alpha is, what do you say, 0.05. So look at two-tailed and alpha of 0.05, 2.238, 2.228. Okay, that's your t-value, t-score. Now, under this square root, that's the exact same thing that we did right under here. Okay? And when we did this earlier, what did we store it in? What variable? B. So let's just, can you do both? Get alpha B. Let's see what alpha B is. And you could just put B here if you wanted to, but for the video I want to show that it's an actual number. 23.1324185. Okay? Times the square root of, remember this is 1 over 6 plus 1 over 6, so that's 2/6. Which 2/6 is equal to what? 1/3, so let's call that 1/3. Now we're going to type that in with a plus and a minus. And this is a confidence interval for the difference between the two means. So what we're figuring out here is what the possible difference between the population means would be between mean 1 and mean 2. That's what we're trying to figure out. If you type it in with a plus, you should get this right answer. Type it in with a minus, you're going to get the left answer. Go ahead and type it in. Now you can do it like this if you want. You could type the actual numbers in, or you could type alpha A, because we have the difference in the mean stored in A. Let's try it with letters. Try it with letters. Clear it once. Let's try it this way. Alpha A, yep, minus 2.228. What do we store this value in? B. So square root of B times square root of, we store this in C, square root of C. Anyone else get that? Okay. So we got a lower value, lower bound of negative 5.854 minutes. Go ahead and now hit second enter. Change that minus to a plus. Enter. 6.520 if you round that to 3 decimal places, minutes. And actually, how are you supposed to round confidence intervals? Do you guys remember? That's proportions. Proportions go to 3 decimal places. If you put in raw data, we put in whole numbers for raw data, so what would I round the answer to? 1, yep. If you put in whole numbers, you go out 1 more decimal place, so it'd actually be negative 5.9 minutes is less than mu1 minus mu2 is less than 6.5 minutes. So from this, is it possible that maybe these are equal? And how would we know? That's what we're really trying to figure out, right? Aren't we trying to figure out whether it's possible that the average time of brown mouse, of all the brown mice in the world run the maze, this could be the same as the average time of all the white mice in the world run the maze? I'm trying to figure out if these could be equal. I say they could be. I say it's possible that brown mice and white mice have the same intelligence. How would this make me believe that, though? Right, 0. If these were the same and you subtract them, you'd get 0. 0 is between negative 5.9 and 6.5. So because it's possible that this equals 0, right, because 0 is between these two numbers, and we're 95% confident of that, because it's possible that this equals 0, and you could add mu sub 2 to both sides, it's also possible, in fact we're 95% confident, that mu 1 equals mu 2. Keep in mind though that alpha is 0.05. That means there's a 5% chance that we would reject the null even if it's true. This p-value here, where's the p-value? Right here. This means that if the null is true, there's still more than a 50% chance that we'll get a value, a test value at 0.1199 or a more extreme value. That's what the p-value tells us. A lot to remember, I know, but that's why I just keep going over it again and again. Any questions? Okay, that's good.